Hello friends, today we will discuss about G Fanuc Versamax PLC programming, downloading and simulation. So this is the first window. We will create an empty project. You select this one. OK. You will give a name PME 14 July 22. Then OK. Then right click, add target, G Fanuc controller, Versamax micro PLC. No micro, I have micro PLC. So now this tree is already created. Here hardware configuration. This is by default. This is the CPU number of Versamax PLC. Now we will create a program block. Now it is empty. We will make a program for a motor starter. So we will use this contact blocks, normally open, one normally close, then one coil for motor. This is for start push button, this is for stop push button, this one motor. And now we have for a motor, there is one hold on contact is required to so that the motor will get continuous supply. So we will one. Then we will have two indications. One is motor on indication and one is motor off indication. So we will use one no block here. It will give an output and one NC block. It will give one more output. Now we will give variables, new variable boolean. So the first one is start. So here you have to give a reference address, this type of input. This is discrete input or digital input. Now you can see it is assigned one number I1. Then we will create one more. It will give stop. This is also digital input or discrete input. So it is by default to 2. Now give motor, it is output. New variable boolean. Give motor. This is discrete output or digital output. Now we see that the motor is gone up. We want to, it should be, so here we will sort it by address, so that start stop motor is in sequence. Now here we will assign our IP start. This is motor. This is hold on contact for motor. Now this is the on indication. When the motor running, it gives an indication. So this also give motor. This is your Q2. Still not assigned. We will assign one more output. This is your motor. M on or MOT on. O motor on. I will give one more. Motor off. This one we will assign first. Motor on. This will be your digital output. Motor on. So it is already Q2. Now we'll make one more.
This is our board, electrical board for system integration, and this is our Engg PLC. Now we will power up. Now you can see the two LEDs is blue. One is for power. If power is okay, it will give okay indication. If everything hardware is okay, it will give okay indication. When you run, there will be one more indication will come, run indication. So this is a 16 input and 12 output PLC.
For downloading the program, we have to validate it. So now we'll validate. The message is validating complete, zero warning, zero message. Now we will go to online. Now the device is connected. Here you can see the Q3 output is on because the motor in off condition. So this is in motor off indication is on. That one we can see in the PLC also.
Q3 is on. Q3 means motor off indication.
Now we will force the input. Now I will force the start. Now you can see the motor current starts flow from here. This LC button, this is hold on contact. The motor on and motor on indication on. This one we can see in the controller also.
That we can see in the PLC, the Q3 is off and Q1, Q2 are on.
Now the motor is in running condition. So two indications are on, motor on and motor on. Now we will apply force on stop push button. Now see the current brake here, the motor off and the indication gone, on indication, off indication on. This one we can see in the controller also, PLC also.
Now you can see only Q3 means motor off indication is on. Good morning, friends. In the last session, we have seen the overview of our 1500 kVA control panel power diagram and control diagram. So here, there is one main incomer which is feeding to the copper bus bar systems. Bus bars are the copper flat bars. It is used instead of wire, flexible wires due to some technical reasons. Then from the bus bar, there will be one branch breaker Q1. It will be Q1 will feed to 3 set of contactors K1.1, K1.2, K1.3. Again, one with each contactor will feed to capacitor of banks parallel to each other. And here it is 25 kVA, 25 kVA, total 50 kVA. Designation is 1C1 and 1C2. The second set is K1.2 and it is feeding to 1C3, 1C4, 50 kVA, 25 kVA average. The third set is K1.3, it is feeding to 12.5 kVA each contactor capacitor banks. And designation is C1, C5, 1, C6. For the other branch circuit branches, we have represented in a single diagram form. The branch breakers are Q2 to Q12 and the contactor and the capacitors are designated accordingly. Coming to the control circuit, we have our 480 volt system. But since some components are wired onto the door, like push button pilot lights, this 480 volt cannot be used as a control voltage, because by some accidental contact, if you get somebody touch the come in contact with any light parts, he will severely get shocked. So we have reduced the voltage to a safe limit. So our control voltages are 230, 110, 48, 24, AC or DC, depending on the system requirement. So here we have one control transformer, 480 to 30 volt. It is connected to phase, either RY or YB or BR. Then in the primary, there will be one fuse protecting the coil of this transformer. And secondary, there will be one fuse. So here the output will be 230 volt AC. This is phase and this is neutral for the control system. Now there will be one auto manual switch. In auto mode, when the switch turn to right auto mode, the power come to here and there will be one controller contact inside the controller. Depending on the signal, it will be switch on, is it closed or open. So when it closes, the power come here and all the this contactor coils are get energized. The contactor is like a magnetic switch. When this coil gets applied, it magnetic field forms and it pulls a moving part. So one fixed part and moving part are get closed here. So and since there is a pilot light parallel to the coil, so it gives indication that the contactor is switched on. So obviously it is when the contactor switch on, the capacitor will be charged. So this PL1 when glow, it will be indication that capacitor banks are on. In manual mode, when the switch is turned to left, the supply come here, then it pass through a stop push button or open push button. It will have a normally closed contact. Normally closed means in normal condition it will be this contact remains always closed condition. And this is one closing push button. This is normally open contact. These are all spring operated. So when you press this, the contact current come here and come to this contactor gets supplied. But when you leave this switch, push button, this contactor gets off. So to latch it, we are using one NO contact of this contactor as just a latching. The function is like this. When you press this button, this energizes, and the auxiliary contact is some contact of it. It is some auxiliary contact. It closes when the coil gets applied. This also closes, and now current carries this path and this path. So even when you leave this push button, the current continues in this path. So it remains in the closed condition. If you want to break the switch, break the path, you have to press this. If you press this, then this will not close automatically unless you press it. And there is a center of position, automatic switch of center of position. When you want to de-energize the system, if you don't want to operate in either auto or manual mode, you can put in center position. Or if you want to make some maintenance or repair work, you can put this in center position. For others the same principle, but here the switch is gang operated. When you turn the switch to manual mode, all the switches will be turned, all the contact will be changed to manual mode or auto mode. And here this is general representation for circuit PL2 to 12. So pilot lights are represented by PL2 to PL12. Now the next chapter we will see the wiring diagram of the controller. This is a typical diagram of a controller. So here our supply voltage is 230 voltage control supply. Now this controller have options for 400 volt, 230 volt, 110 volt, and 0 is common. We have to apply the voltage depending upon availability. Then there is 2 points K and I. This is crucial because these 2 points receive the signal from the main panel, main system. Main system means suppose this is your main panel. It is feeding to blower, water pump, lift, lighting, workshop, exhaust fan, all the loads. So some loads are like blower, water pump, all have or inductive loads. So depending upon the operation of these loads, the power factor, the current, nature of the current is lagging because of inductive load. So depending on the load, this will give these are the current transformers for metering of this panel, but there will be one fourth CT current transformer. This will feed to this point K and I. So this is a comparator. Inside we have to put the target power factor 0.98 or 97 or 96. And the comparator will compare the nature of the power factor of the system, and it will give signal to close these contacts 1 to 12. So depending upon how many kVA required, these contacts are closed or open. Suppose the load is some loads are switched off, then the power factor improves. So in that case, some capacitors are switched off automatically depending by this controller contacts. Here this point A is for supply coming from here because the current should pass through the contact and come to this is a relay or contactor. Some cases, if the contactor size is small, it directly feeds the contactors, and if some cases, if the contactors are big size, or there are more than more contacts. Like in our case, we have 3 contactors in parallel. So the load comes to this point. In that case, this contact will burn, and since it is inside the contact, we can repair it. In that case, so to avoid this, we are using one small relay. It will have only small auxiliary contacts, and this contact will not damage, and this yellow contact will energize the main contactor, big power contactors. This is called capacitor duty contactors, because there are many types of contactors, lighting contactor, for motor switching contactor, but this is special type, so this is called CDC or capacitor duty contactors. Now in the next topic we will see use of reactors, detuned reactors. Okay. So this is the overview of our system. The left side upper portion is a power diagram, the lower side is control diagram, and right side is a controller diagram, and extreme right side is main panel. In the next topic we will discuss about the detuned reactors and the creation of pillar metal for this panel. So this is the electrical equivalent of or electrical diagram equivalent of logic. In our electrical diagram, we have one auto manual switch. So here, this is the auto. This is the this is the manual. Now, when we close this auto manual position, one lamp is running, glowing. This is indicates the manual mode is on. When we close this, when turn the switch to auto mode, this lamp is indicating auto mode. And in manual mode, we have seen we have now this is our switch. When you turn this left, the contact block is this side. This is giving power to go to this. But turn right, this auto mode is running. So always there will be in either auto or manual. So here that one we represented by one interlock, means if you try to close both switch, you see what happens. Now this is in manual mode, so one on, and when this auto mode on, when I try to close, when auto is on, I try to close this, you can see both the are off, because the current is blocking up to here. Red line means there is a blocking current. Blue means there is no current. So because of interlock between these two, the line is blocked here. Okay, then we have our push buttons. We have our for manual mode. We have push buttons. We are represented by. So suppose we will put this in our manual mode. We will see all the manual modes are closed. Here this is a 4-stage controller. So there will be 4 stage Q1, then here 1 second stage. This is 3rd stage. And this is 4th stage. So you can see all the manual modes are on. Now we will switch on the capacitors one by one. Now this manual mode, I will close this. So by push button, there is one contactor in our electrical circuit. This electrical circuit, when we close this push button, this contactor energizes, and because the contactor is closing one capacitor 10 kVA. So this is our output. This is 10 kVA capacitor switch on because of the first set. Now coming to second set, now we will close this. So this again contacting closing contact K2. And so our second capacitor is 15 kVA, which is switched on. Now coming to 3rd stage, I am closing this. So contactor closing the 20 kVA capacitor. So 3rd capacitor is on. Now coming to fourth stage, this is the one equal to K4 and K1. So now all the capacitors are in manual mode. Now I want to switch off one by one. So for that I will switch off this push button of fourth gun, the third gun, second gun, first gun. So this is the manual operation of the push button and contactor and capacitor. Now we will reset all. Now we will turn the switch into auto mode. So this is your auto mode. This is your auto mode. Now turn the color auto, and this is also showing auto mode. Now this is in our diagram. We can see these are the push buttons. When you press this, while currently here, this is spring operated. This will be closed momentarily, and this is the one for this is one NO contactor. This is an NC contactor. So these are on off. Then these are the contactors which control which give supply to, which give power to the capacitors. This is a special duty contactor called the capacitivity contactors. These are the pilot lights. It indicates on or off indication. These are the capacitors. Now this is the controller, which is the heart of the system. If you will see backside, there will be one switching devices. There are some switching devices. Depending on our requirement, these are give a signal to close the contactors to close, open or close the contactors. So now in our system, we will consider this as auto contactor. One signal. Suppose the signal came to switch on one 10 kVA contactor, so this will close. This is control give. Now you see this 10 kVA capacitor is on. Now suppose the demand requires more, additional 15 kVA. So the second contactor will close from the controller. Now we see one 15 kVA capacitor is on now. Now it's 25, 10 plus 15. Now still we need 20 kVA. So what we will do? This controller gives 20 kVA. Good. Now this is the 10, 15, 20. 10 plus 15, 25 plus 20, 45. 45, then you need still 25. So this will close. Now all capacitors 10, 15, 10, 15, 20 and 25 all around. Now suppose some inductive loads are switched off, like blower or pump or some lift or switched off escalator. Then power factor improvement means suppose you need to reduce your capacitors one switch off. So here switch off is controlling C controller 1. So this contactor will open. Now still some further loads are closed, stopped. So we need to switch off on 15 kVA capacitor. So controller will give command to switch open this contact. Still you need, so by this we can switch off, automatically switch off all these contacts. So now only all are switched off. So this is the how the controller works. ये एक एलईडी प्रोसेसर सर्किट है, इसमें एक वेरिएबल रेजिस्टेंस यूज हुआ है एलईडी का फ्लश रेट ज़्यादा कम करने के लिए, और ये उसका एक्चुअल सिस्टम है। तो पहले हम सर्किट सिमुलेशन करेंगे, फिर बाद में इसको करेंगे। तो इसको हम पहले हम रेजिस्टेंस कम करेंगे। फिर रेजिस्टेंस से बढ़ाएंगे। अभी स्लो हो रहा है। अभी एक्चुअल सिस्टम है, ये इसका पॉट है वेरिएबल रेजिस्टेंस के। अभी इसको अभी फ्लश रेट ज़्यादा हो रहा है, फ्लशिंग रेट ये पॉट की वजह से। ये लोएस्ट रेट है। ये हाईएस्ट रेट है। This is the circuit diagram and the light circuit of a motor control system. In place of motor, here we have a bulb. These are the push button, start push button. We can start the motor, we can stop this red push button. And these are the indication lights. This green light indicate when motor run, this glow. The red lamp glow when motor off, and due to some reason, if motor draw heavy current, more current, this motor will trip and this will give the yellow lamp glow. So now we start this motor by pressing this green button, and we can stop by pressing red button. If we want to run the motor or stop the motor from a remote location like control room or control outside plant. This is a remote control station, so we can start and stop remotely. This is a lighting control panel. We can control a light or a group of lights by this panel. It has two modes, manual and auto. In manual mode, we can turn to manual position the switch, it will glow. In auto mode, it will be controlled by this sensor, dark and light sensor, also known as a photo cell. So now we will turn to auto mode. After sensing light, we we switch off the bulb. Now we will make our system dark. After sensing dark, it switch on the light. It is mostly used in street light application. In the evening, the system will switch on the street lights. In the morning, it will be switch off the lights automatically due to this sensor. Now it switch off due to the light. Now this is called programmable logic controller. It is used for automation systems. Now the switch is manual auto switch. Now when we put this switch in auto mode, this motor or bulb will be controlled by this PLC. So it will be there is a sensor here. The sensor is connected to a relay. A relay will give signal to the PLC and the PLC will switch on this light. Now due to presence of light, we switch off. Now we will make our system dark. After sensing dark, it switch on the light. Now here, this relay was before not activated. After getting a signal, the relay activated, it will give signal to the PLC and the PLC give switch on the light. This is how an automation system works. So now we will have a little comparison between the conventional system and the automation system. In this conventional system, the sensor is directly connected to a panel. But in automation system, these sensors are connected in the field, and from field signals come to activate a relay. Now the relay is in off condition. When we switch off the light, we will get a signal from the field. Now the relay is activated and this signal is processed. So in an automation system like this, lot of parameters we can control. If you want to control temperature, we can connect a signal to this relay, and if you want to control a pump which is filling an overhead tank, when the overhead tank fill, it can stop the motor from this PLC. If the underground tank is become empty, it can stop the motor to prevent dry around. It can control humidity. So many things can be controlled by PLC. Thank you. As we discussed, this is known as programmable logic controller or PLC, which is the heart of the system. The first module is called CPU, Central Processing Unit, like computer. It processes the data. And the second one is extension module. There are two types of input output. One is digital and another one is analog. When we need only switch on, switch off function, we use analog input, analog output. This first unit consists of CPU and I/O, digital I/O, and the second unit is analog I/O. So this when we need continuous monitoring temperature, pressure, or humidity, we connect the data here. The PLC also have many ports for networking, Ethernet port, Modbus, Profibus, all this, so that that it can be, the data can be communicated to different departments in different systems. This is a typical SCADA screen. SCADA means supervisory control and data acquisition. In this screen, every equipment in the plant, graphic made to be for each equipment in the plant, and there will be sensors in the plant. We have to take the data. So here we can see the actual monitoring system. This is a small program for motor control. This is our motor stop condition. This is lamp blow. This is motor stop condition. Now from soft switch, from SCADA button, these are SCADA buttons, we can start this from this here. So after this, the motor starts rolling. This is your motor rolling indication. Now if we will switch off, we will stop here. Now this is motor stop indication again. We can start from here again. In case motor over, motor stop and also give trip indication. So this is a small example of SCADA screen. Thank you.
Good morning, friends. Let us, I am introducing myself a little about our projects. So this is basically for skill development. We have two sections. One is industrial training and education center. This is very basic level. It will be suitable for those who want to work as a fitter, welder, electrician, industrial electrician, draftsman, computer, etc. And the higher version is electrical control and automation training institute. It is for advanced level people. So this is we are going to start a we are going to give about a particular electrical product. This is called electrical low voltage electrical control panel. Okay. Control panel is like anything that controls the system, like your car, bike, accelerator is a control, brake is a control, gear is a control device. So by using three devices, you are controlling the vehicle. Here, electrical system also controlled by the device and the control panel.
If it can't control, is no what happens. The what thing is satisfied. It is soft, electric soft to any surface. Okay, now this is our product. Now I am going to show you a 3D view of our product. So this is our 3D view product. You can rotate it in any position to view it. Okay. Now let us give some part identification. So this is the biggest one. It's called air circuit breaker, or in short ACB. Then this is called boulder case circuit breaker, or MCCB. Okay. Then the smallest one is called miniature circuit breaker, popularly known as the MCB. Now regarding connection, you can see how this one power your cable will connect from the bottom side. Then this is a switch, this is 4,000, 2,000, 500, 5,000, okay, 6,000, 800 maximum. It will go to the current flows through a copper or aluminum bars, flat bars. There is some thickness here, you can see. You can see there is some thickness here. 5 mm, 10 mm, something. So the power transfers from the power starts from here. Then it go to a distributor system. This one, then it comes down. Then here again goes to the branches. This is called branches. This is called main, and this is called branch. Okay. This is called main. Incomer. These are called branches. Outgoing or branches. And these are called sub branches.
Why it is called sub branches? If you will see that side, this breaker is connected to the direct cable connection outside, but this breaker goes to the back side of this. It is the back side. It is going to back side, and there is a called one more distributor system, and from again here, power going branches to this mini LCBs. So this is called the sub branches. Our electrical diagram this is our electrical diagram of the system. You can see one incomer is going to here. Same thing we have going to electrically. This is called the incomer. This is called outgoing one. This is called outgoing two. There is here sound mistake. It comes to sound comes to right, but it should be come to it will come here and here. That we did not solve. Now coming back to our model, this is what. Now we will. So this is we have shown in our slide, or that this is a product inverse mechanical electrical instrumentation work. So we will start with mechanical first. Further to our first member is now this is dimension. It is dimension important. This is 1000 height, 1 meter height, and there is one more chamber distribution. This one is called busbar chamber. Why it is kept in a separately? There is a reason. Because nobody will be open this chamber. Only a qualified person can open this. People will open only this area only. If you want to see something, even this field there will be a door in this. I have not shown it. There is a door on it. It will open to the indoor closed condition. But if somebody want to see something, he will open, allowed to see open this area only. This will be closed by like a door. There will be a hinge door. There will be hinges. They open. But this chamber is always with a bolted cover. It is bolted because it is highly high risk. All these are live parts here. Even this will be also covered. This bus bar will be covered. If you open, you cannot see this bus bars. Okay, so let us start with one member. This member. In our drawing, it is 1000, but for workshop purpose, I split it into two actually. There is a 500, 500. So this is our 500 part. So this is basically a angle of 25 mm 1 inch or 30 mm. We have made it 935. The length is our 500 mm. Now we will make it 1000 mm. How? So for that we will add we have several things in height condition. Okay. To make this joint container, you need to make a bracket here, small bracket. One side will hold weld here. And one side there will be a welding inside, and there will be one hole here. Then we need one more same piece. So now you can see it is now a 500 plus 500. There will be two brackets this side, and there will be a bolting hole for bolting. So now we got a one frame. Now like this. Now to hold it, we need one more little frame outside. Okay. We are trying to do by animation, but till now we have not. Now we will need one more this here and one more here. Okay. This is the front side and this is your depth wise depth frame. Now regarding this dimension of how much this should be, because your dimension is your 600 mm. So and one frame size is 25 mm. This frame. So to make 200 by 200, you will need this frame. This frame should be